and we'll move on to the final talk of our afternoon, which is being given by Professor Paul Monks, who's the Chief Scientific Advisor for the Department for Business, Energy and Industrial Strategy. And he's going to talk about how can science inform policy on use of air cleaning in schools. And so over to you, Paul, if you want to share your presentation.
Thank you very much, Paul. And I'll just, as you say, share my presentation, which hopefully you can now see.
Yes, and I can hear you.
Super, and you can hear me, great. So thank you very much for inviting me along today. And I hope this talk, which is in some senses at a relatively high level, and hopefully isn't too much of a statement to the obvious, will be helpful. But I've been asked to really think a little bit about how science informs policy, particularly around air cleaning in schools. I'm going to really talk about the general science on ventilation and air cleaning in buildings. And I've got to acknowledge Kath Noakes, who's Professor of Civil Engineering at Leeds, who's helped me with this and who I've worked with through SAGE work when we've been thinking about this and might be known to many of you on this call. So before we kind of think a little bit about ventilation, you've got to think a little bit around what are the routes of transmission of a virus, or in this case SARS-CoV-2. And there's a really good tool that was put together by a couple of people from the EMG group through expert solicitation that looked at the different ways that you can do it, from touch and breathing, from the fine aerosol and the droplets and the surface transmission routes. And they thought a little bit around, as you take these up and down, what the relative transmission of these groups were. And they published actually this in the BMJ, the British Medical Journal, and there's a really good interactive tool that helps us think a little bit around that. And you can actually change the ventilation in that to give you a feel for that. So when thinking about the role of ventilation in schools, the thing to think about is, well, what is a transmission route, and what are we mitigating as part of that transmission route? And that brings us really to thinking about something quite important before you jump into this, which might be fairly obvious to everyone who's on this call. But when you're talking about science and turning that into policy, you've got to think about what role does ventilation play among the other controls that you can do. And you'll probably know this is called the hierarchy of control, which says, if you can eliminate the hazard, that's the most effective way of doing it. You can substitute the hazard, that's the next most. Then if you can isolate the people from hazard, you can put an engineering control in place. That's the next method, all the way down to personal protective equipment, which is the least effective in that hierarchy of control. And I think it's very important to think and absolutely say at the outset, ventilation is not the silver bullet to stopping disease transmission. You've got to think of it in terms of these hierarchies of control. And as you can see here with ventilation, it really is just one of those controls. It's got to be worked into a more holistic plan, a more holistic hierarchical control risk assessment in terms of doing that. And ventilation really only mitigates the airborne transmission that kind of longer range, though we can debate around that. Of course, that gets down to later questions around ventilation rates and their effectiveness and CO2 monitoring. So very much, got to think around ventilation and its role in schools as part of that hierarchy of control in terms of reducing the effectiveness of the mitigation. And we're all familiar with the Swiss cheese model for this. It says what we've actually got to do is stack these controls to make sure that we minimize or prevent the spread. And we recognize that no single intervention is perfect at doing that. I think the other interesting thing that the hierarchy, the Swiss cheese model, as it's often called, says is that actually there's also a distinction between the personal responsibilities, what people can do personally in those sort of controls, versus what the shared responsibilities are. So I think putting those two sets of things together is very important when we're thinking about these sort of things. And you can see there is ventilation on that shared responsibility around that, but it sits as that wider piece, if you will. So to do ventilation, just some obvious kind of 101 things of ventilation, the principles behind it. We've got mechanical ventilation, which can go from the simple to the quite complicated. It's very easy to control. You can control the air distribution. You can also filter it. It's very hard to retrofit. And also we've got the natural ventilation. And many, many buildings we're going to be dealing with, particularly older buildings, are naturally ventilated. It's very uncontrollable. It's very variable. It also links more heavily the outdoor, the indoor. Natural ventilation on one level is quite simple, but it's hard to get right. So the first sort of thing when thinking about ventilation and air quality monitoring in schools is obviously the system. And then, of course, you've got to think around the how much ventilation do you need? And obviously the risk is going to depend on the duration, the activity, the viral load, the number of people, and recognizing that airborne transmission, particularly the SARS-CoV-19 virus, can be one to many. And clearly, more people equals a higher chance of the infector, and more people get infected. And you can see that the relative airborne risk drops in a very non-linear fashion with ventilation rate. And you can see there is a point where increasing the ventilation rate doesn't increase the relative risk proportionally as you go down that curve, which is, of course, quite an important driver of the strategy that you put in place in terms of the science policy interaction around ventilation. So what is then for the appropriate measure from that? So we look and use CO2 as a measure for that. And you've probably talked about that the estimation from models, but actually on the early variants, about 10 litres per second per person is about right. It equals about 800 ppm of CO2, which also happens to fit to the CIBC and the UK building regulation standards for most spaces. But you've got to think about how those spaces are used. There's obviously going to be a higher risk for aerobic exercise in school gyms and the like, and high aerosol generating activities. There is also going to be as we've seen with the difference between Delta and Omicron in terms of transmission, at least, if not impact, that actually you've got to take in the transmissibility of the variant and the viral load dose response curves that also drive that. So the ventilation rate that we set for Delta, would that be the same ventilation that we should set for Omicron around that? But back to this, that actually we can use CO2 as a measure of that. And in a way, there's an important lesson at the bottom of this about the appropriate ventilation rates, that mitigating poor ventilation is likely to be more beneficial than further improving good ventilation. There's a law of diminishing returns, as I showed you from that curve, around the ventilation rates in a given space. I think one of the things about ventilation is also the awareness of it as part of this. Ventilation is very hard to measure. It's invisible. Many organizations miss it in their risk assessment. The public are less aware. Maybe that's changed a little bit with the hands-face space as part of the public engagement on it. Often there's very little data on that, and many people rely on windows. So actually, the agency and the ability of people to change ventilation is variable in very different settings, and many organizations are quite reluctant. So actually, I guess CO2 measurement very much drives that, making something that's hard to measure and slightly invisible visible as an important tool as part of that. So that's the kind of science. Yeah, and you might say, well, I've just told you everything that you really know about this. But that's the way that we frame the science at a very top level, and very much talking to DFE colleagues who are responsible for the policy behind this. This kind of high level of framing is what is used. And from my experience of working in a government department and setting some of the workplace guidance on working with people like HSC, is that framing at this kind of very high level, which is actually quite generic, because it's got to apply to most places. And too many caveats make it too complicated for people to be able to apply. So if we can't ventilate a space well, what about the role for air cleaning? So that is application of technology to remove or inactivate microorganisms. It's not a reason to reduce that. It can be portable or fixed systems. but also you can make changes to HVAC systems as well, and it can be single pass or upper room with something like UV. There's a wide range of technologies that are available, and very much the scientific evidence on this, and I was involved in this during the SAGE process, says there really are two that are the best. That is HEPA, the physical filtering of organic material from the atmosphere, and also the use of UVC that inactivates pathogens. Again, colleagues from the DFE have said, that actually there isn't currently a guideline for the safe exposure of UVC in school classrooms. That's something that's got to be borne in mind. There are out there a plethora of other devices, ionization, plasma, chemical, and when we looked and reviewed those, the evidence about their effectivity was fairly short, and in fact some of them could even in fact pose risks in there. And clearly in a classroom you want that safe technology to be available. You do not want to expose people to anything beyond the virus. So obviously air cleaning applications, it can benefit when ventilation is poor or hard to provide. As I said, HEPA filters are UVC, are likely to be beneficial. As I've said, these other devices have less evidence around them. There is controlled test data, particularly on the HEPA filters, and we've seen it used in some hospital environments, particularly effectively to reduce risk from into bedroom transmission, particularly in quarantine facilities. So that can be effectively. Anybody who's an expert in ventilation will tell you it depends on the geometry, the ventilation rates, the even opening the window, the positive and negative pressures. These are complicated issues, but when you're setting science to policy advice, you've got to take this sometimes at the highest level. And I've just said this, sometimes the effectiveness absolutely depends on the size of the room, the design of the device, and the placement of that device in the room as well. And you've got to think about that quite closely. And a number of studies where they've done this have shown that real thought has to be given to that in order to get the effectiveness of these air cleaning approaches. So a summary there on the portable devices. HEPA physically traps the aerosols. It works on particles down to about 0.3 microns. It can be very good for other particulates as well. It can be a little bit noisy, but the modern ones are actually quite good, but they do need servicing and monitoring and changing as well. UVC does inactivate microorganisms, doesn't remove them. It's not effective on some other contaminants. It can be quite quiet, but again, it does need annual maintenance as well. So in a way, when we're thinking about advice, in the school's context, these are the generic things that you need to consider. How many units? Is there space for units? What's the noise? What is the capital investment? Do you need specialist design installation? What maintenance is required? Are there any safety considerations? What evidence is there for effectiveness? Are there any other knock-on impacts? Comfort, energy at the moment, very salient. Are there any other wider benefits you do get with the HEPA filters, that control of outdoor pollutants as well? And how will people respond to the use of technology? What we often say sometimes around the use of technology, particularly these sort of devices in spaces, is that it makes people not take the effective measures, the other measures they can take. They feel that solved the problem, and that actually can be a real problem if people think they're safe when because they've got these devices, they've got that kind of false sense of security, if you will. So these are the things that you need to consider. So a little bit about the translation to policy and that. Throughout the pandemic, the SAGE Environment and Modelling Group and the Transmission Subgroup, which I chair, and I'm a member of the Environment and Modelling Group, have pulled together all the environmental modelling data analysis and to play an understanding in this role of COVID-19 transmission. As I said earlier, we've looked at transmission routes, the factors that influence those transmission routes, right back to that opening slide around this. And we looked at the impact of environment and behavioural interactions. Because I think it's often, as the point I was, I think, somewhat clumsily trying to make on that last slide, that environment has got to be a combination of yes, the ventilation rate of the room or the effectiveness of the device, but also it's the way that people change their behaviours as well because of that, around that. And you've got to look at those mitigations at a mechanistic level. If you're interested, and it's probably published on the web, SAGMG produced 2 key papers on the role of air cleaning devices. But actually, what they both say is they're a useful strategy to reduce airborne transmission risks in poorly ventilated space, but no substitute for adequate mechanical or natural ventilation. And that comes back to that hierarchy of control. They're not a substitution, they're an additionality around that, and got to be considered absolutely in the round. I think there's another challenge as part of this. Within the Department of Business, Energy and Industrial Strategy, we are the sponsor for the Office of Product Safety and Standards, OPSS, and many of these technologies are a little bit of a black box. The regulators, depending on the element that we're talking about, particularly with air cleaners, are either trading standards, HSE, the Advertising Standards Agency. You know, is somebody advertising a product that is wrong with right? OPSS, the Office of Product Safety Standards, and also if it's a medical area, MHRA on devices. And actually, a number of departments are using these sort of technologies. DFE, we're talking about, obviously, in relation to schools, DLUC, Department for Levelling Up and Housing Communities, ourselves, and the Department for Transport. So it's actually quite a complex regulatory and efficacy landscape, particularly for air cleaners. And I'm happy to explain that at length if there are any more questions around that. So hopefully, you know, what I've told you on this, you know, ventilation is important. It's not a silver bullet. It's one of the key environmental controls. It's particularly important for spaces with high occupancy over long periods, hospitality, schools, workplaces, healthcare. CO2 is a useful proxy, but not a measure of infection risk. I probably didn't talk about that enough, but we use CO2 as a proxy measurement for really ventilation. It doesn't tell us what the aerosol loading or what the effective loading is there, but it's a proxy measure for the ventilation. In the UK, we're currently recommended under 800 ppm V as okay, and greater than 1500 parts per million as poor, and they're reflected in the DFE guidelines as well. CO2 does offer that approach to see invisible and does enable that mitigation, identifying poorly ventilated spaces, support continuous active management of ventilation, and balance ventilation with comfort and energy, which is key. Air cleaning technology can be used. It's likely to be beneficial, particularly where ventilation is poor, but the evidence of efficacy and safety is weaker. And really, all this has got to be absolutely wrapped up within the hierarchy of control. So, you know, in preparing this talk, I discussed with our DFE colleagues around this. This is the science that's really underpinned the policy in terms of the workplace guidance. And they tell me very much that this is the same sort of evidence base that they've drawn from in the guidance they're currently giving to schools at the moment. And it's that level of taking that firm scientific understanding and translating it clearly into policy, which is part of it. And I hope you found that probably what is to you, if you're experts in this area, quite a simplistic view, but actually often when we're translating science to policy, it's very important to be clear about what's going on. And I'm happy to accept any questions that you may have now. Thank you very much, Paul.
Well, thank you very much, Paul. It's a very interesting perspective. Thank you. I've got a question which I think is certainly one that I have as well from Tom Sturgeon, who says, you know, your context at the moment is very driven by COVID, but and his question is it expected that air cleaning will continue to be a focus on transmissible diseases, or will it be on other aspects of air pollution? And TAPAS itself, of course, is associated with, is concerned with air pollution, and we have been influenced, obviously, by the pandemic. But I wonder how you view the sort of broader context of air quality in schools.
Yeah, so I can see Nick Carswell. Hi, Nick, how are you? So I think that's an interesting question. So I think there's two things moving forward on this. If I look at the science to policy again, it's going to become generally about how can we mitigate respiratory diseases in general. Around that. So you're right, you know, the living with COVID is in some sense living with respiratory disease and the role that ventilation plays in that. I think that it's probably highlighted an interesting area in terms of air pollution, which, you know, from my background, I know a lot about. I think it's focused a lot of people's minds on the issues around indoor air pollution. there's no doubt, isn't there, that, as I said, if the mitigation method for reducing transmission in schools or poor ventilation, which is recognized as reducing the amount of concentration times and all the sort of things like that around school, means you open windows and you increase the amount of outdoor air pollution. There's got to be an offset in this. So I think that if you talk from a policy perspective, it's absolutely focused at the moment on the science policy perspective. It's absolutely focused on the moment at transmissibility in schools. But I think it opens up a lot of very interesting questions around indoor air quality in schools that kind of the pandemic is going to be brought to the fore. I think there are clear guidelines and limits for outdoor air pollution. And there'd be an interesting question about how they translate into indoor as well. I think I do know that schools, particularly near roadsides in mainland European countries, actually have mitigation methods in place to reduce the amount of external car-based air pollution coming in there. So some schools are taking those sort of measures, but I think it'll bring this question to the fore of what the right balance between these two things are.
Thank you. And Nick, do you want to ask a question?
Yeah, hi, Paul. I just wanted to ask you about regulation. We were talking about this earlier. I'm saying that one of the problems that schools face is that there are lots of these air cleaners out on the market, many of which operate on snake oil principles, shall we say. So one thing that would be really helpful would be if there was some sort of regulation around these instruments. So I think somebody said earlier this is coming, but in several years' time, but schools need that help now, I think. So it's just, have you got any intelligence on when regulations might be available, or what are your thoughts on regulation, what we need to do?
So I did as part of preparing for this talk kind of push this issue, because I think when we prepared some of the SAGE paperwork around air cleaners, it kind of came, as you said, out that the regulation landscape, as I said on that black box slide, is actually quite complicated. So the evidence is now being captured about these devices in order to build an understanding of their use and any potential issues around them. So OPSS, the Office of Product Safety and Standards, and local trading standards have the responsibility for regulating product safety around this. But actually, there is a difficulty of there's no standard efficacy test for these, as you well know, in order to do that. So I think there's a question about whether there needs to be a British standard around this, or some regulatory framework that we can go to. But at the moment, I think you're right, as you indicate, it's a bit of a regulatory quagmire, isn't it, as to what is a standard and who is the regulator for that standard. So product safety is something that deals with, are you going to electrocute yourself with this? Less so, the Advertising Standards Agency deals with, is this performing as it is advertised to do? Now that seems very odd for something that is like a device like these. And you're right to say some of them are worse than useless as well. And the evidence is actually pretty strong around that uselessness, but that doesn't stop them being sold.
Okay, thank you very much. I think that we've prevailed on you long enough, Paul. So thank you for your time and for coming along.